So let's get started again. Let's switch into a mode where maybe it's a little bit more interactive and also involve people that are writing the test suites themselves. So we can look at like what are all these tests spitting out and what are we actually doing with them and how. So like Tim said, I haven't actually seen his slides, but we've talked about all these things and I think hopefully we can agree on some of the basic terminology. But I guess we hit on this a little bit before lunch, but I kind of wanted to go back to the basics on the simple things, what we're spitting out. So obviously we're spitting out logs and test code and things like that, but especially for maybe the people that are working on test suites, it might be maybe interesting to hear what are the types of artifacts that we're actually talking about besides just logs and how you're being stored. So does anybody want to volunteer for their test suite or for their test kind of tools? What the tests are actually spitting out themselves, not where they go or anything. Just what are they? Let's start with the simple stuff. What are we spitting out here? So we got raw logs, obviously.
Yeah, raw logs. So raw logs. It could be some whatever recorded data, some dump from hardware, right? External hardware.
Some external measuring equipment, data.
We are looking into doing coverage with GCOF, so it could be the GCOF output files for later analysis. That's what I got in mind right now. Anyone else?
Performance data.
Yeah.
Where are all the mics, by the way? Can we get maybe one mic towards the back and one in the middle and one in the... since I'm not running around anymore.
Yeah, performance data, whatever we can capture, right? So we could use tracing and get a log out of ftrace, whatever.
Are people interested in like memory consumption and CPU consumption, all that type
Sure.
of things during the test? I mean, all that stuff, right?
That's part of what we call performance data.
Performance data, okay, that's a good term. I mean, part of the exercise here is I think a lot of us are restating the obvious things, but I also want to make sure we're using. It's helpful to get the same words and know what other people are calling these things too. So it may seem kind of silly and obvious, but feel free to state out the silly and obvious, right?
Yeah, so, for the real-time testing that I was doing last year, we were interested in running interference workloads of various kinds, not just cyclic test plus Hackbench, right? And during that, you also wanted to see memory utilization, CPU utilization, and it's like, well, how do you exactly go about doing all of these, getting all of this data without affecting what you're trying to test, which is, you're hammering on the system that's trying to run preempt RT, and then you have to try to get other data and everything into it. But literally anything you can think of, I want that data.
And then the data collection is also an interference workload.
Yeah.
Yeah. So we had a system that, in order to get around any kind of file system hits, we basically just netcatted the data off to a listener. That was the way to get, to have the least impact we could think of on the system.
So minimizing overhead of all the collection too is a priority.
Actually, for the 0D side, we actually catch pretty everything, like the demessage during the execution, also the power consumption. So we connect some external devices, and also various monitors that can decided by the user, like the memory consumption, the CPU consumption, nearly everything. So we try to catch up.
So for you guys, how much is happening with external equipment versus how much is actually running on the target?
For the external side, we usually have the demessage, the serial, and the power consumption tools.
Okay.
Yeah, that are the most used in our system.
Okay.
And the other are running on the test target.
Okay.
And, one more thing we capture is what we call text execution engine comments. It's an optional field, but this is if you have logic in your execution engine to detect like setup problems or so we put that comment there, so it's easy when we process the aggregated results. We can easily identify, oh, this test failed because of, there was an issue with NFS or.
Yeah. I think what Lava calls those infrastructure errors or something, but something to separate failures unrelated to the actual test failure. Yeah. By the way, what are the other terms for that? I mean, there's basically you have test failures and non-test failures, but I think a lot of people have different terms for all the various things that can go wrong. Lava just calls them all infrastructure errors, but they each have kind of types of categories, like your networking failed, or your U-boot didn't actually come up, or your PDU didn't actually reset your board, or all these types of things. But it's nice about VMs, you don't have to worry about some of these things. Anyway, I think that the artifacts themselves are interesting in themselves, but I think the more important thing, for this group, it would be helpful if we could figure out common ways well, first of all, common ways of defining these types of things, and also common ways of actually parsing them, because there's a lot of stuff that's actually happening on target, collecting various data, but we're all talking about collecting the same types of data, so it would be useful to do, especially because we're interested in low overhead on the device, collecting the data, shipping it off target, and actually doing post-processing of some of this data so we can minimize the stuff that runs on the target. Of course, in order to do that and also share it, we'd have to come up with some sort of standard definition for what those things look like. So what are the things the target is spitting out? What are the file formats? What are all the additional data that's related? So go ahead, Dan.
One of the artifacts I would like to be able to get out of tests that we don't currently have out of anything we run is metadata about the individual tests. So for example, test description, like a short description, a long description, things that we can send along with reporting so that when we see a test failure, we can immediately have some context for what it is. And there's other metadata that you could imagine wanting, maybe author, maybe subsystem, you could tie it together with various things.
Yeah, the version of the test suite and how it was compiled and all this type of stuff, yeah.
Maybe it exists in P-test, I see you take the mic. But it doesn't exist anywhere that I've used, and that would be nice if that was available in a structured format that we could then correlate. And that's my other question, is how are you correlating, if you're collecting data from the device during test, how are you correlating that afterwards if you're running 1,000 tests and then you have your test data, but then you have your monitor data from your board? How are you correlating that afterwards to correspond the memory usage, for example, with the test that's running at a time?
Yeah. Are you asking me, or are you asking
I'm asking the room, because we're not currently doing anything like that.
Yeah, and kernel CI is not either, so I'm curious as well.
My comment was just going to be about specifically steps to reproduce tests, because one of the things, we have a lot of testing going on now, but when things fail, the thing that I end up spending a lot of time doing is writing down, telling somebody how to reproduce it. Mm-hmm. And we have that as one-line commands now, very easy, but I still end up having to mention them. So we haven't got to the point where we can self-document them and have those failures easily like that. But
that's a big downside to using Lava features like overlay and stuff, because it makes it harder for people to reproduce it outside of Lava.
Right, and at least for something like OE self-test, we have it down to a single line where somebody can actually just run it in that locally and see the same thing, and then they can usually fix it quickly.
But how does that work with p-test when some of the tests are actually running build side and some of the rest tests are running target side, right?
Right, p-test is harder. So we have it for OE self-test working quite well. P-test definitely not as easy.
So I don't know I don't know OE self-test as well. Maybe you can explain the difference.
And you want, sorry.
OE self-test is about actually testing sort of big workflow changes in the builds. So that is something that you would run on a build server.
Okay.
But the tests themselves can sometimes run very quickly because you don't necessarily need to build a whole load of stuff in order to run some of these things. Some of them you do, some you don't. But if somebody's already submitting patches, it's usually quite easy for them to replicate that. P-test, as you say, you need a virtual machine is what we'd usually use, and then they'd need to boot that up and connect over it. That's all automated with a project, but it's still tiny bit more complex to set up. So yeah, I can definitely see the value in being able to describe these things easily. I guess that's my point.
Yeah, and you do also want reproduction instructions at different levels ideally, so you want to be able to say, here is exactly how to flash this particular binary image that I ran on the target, and things like that, but you also want to be able to say, I built this and you can run it on your other target, which probably can actually reproduce the bug if it's a generic enough bug, without having to have your reproduction instructions tied to, I have this board which is made of unobtainium.
To answer your question about how do you relate or map, performance data to execution. So we use a test management system called TestLink. So, and they actually define all these. We're just reusing that. They have tables for executions and tables for test cases and tables for test plans that are related. So every time we run a test case, there is a new entry in the execution table that you can then, is related to a test case that contains the test case details, is related to a performance table that will contain the metric values and the metric ID, and then there is a metric table that defines what the metric name is, the units, etc. But it's a bunch of relational tables, and they are all tied by the execution table.
So what did you say it was called? TestLink?
TestLink, yeah, it's it was there in 2009 when we started the project.
Okay.
So
Is it still an active project, or is it even an open source project?
it is an open source project, and it is still active.
Okay.
It's a test management system.
Last updated October 6th.
October 6th this year, or of 2009? Okay. So let me say it this way: is it fair to say that if all the test formats were spitting out this type of metadata in a common file or in a common format, would that make adoption pretty much straightforward, or are there other obstacles to actually adopting ingesting this type of common test artifacts in test format?
I think the moment you do have a format, at least if you have it in a different format, then you can write a translator.
Yeah.
Right? At the moment, at least that gets us to where it doesn't matter what format your native stuff is. We can all get it to where it needs to go, so we can share it. It's definitely a start, no matter what. And it's obviously got to be hierarchical or something. So these days that means JSON or YAML, right? Mm-hmm. Nobody does XML anymore, apparently.
I agree 100% with that, and that's actually what we do. We define, this is our test case definition format, and when we plug in a different execution engine, we always have downward translators and upward translators. Downward translate from whatever we define as the test case definition schema to something that particular engine understands, being Lava or BATF or whatever it is. And the upward translator translates from the result in the execution engine format to something that, the common test management system schema understands. So I totally agree with, the first step is defining what this is, then you can always write translators to translate or adapt to your specific framework.
So I think that the downward path that you're talking about is a little bit easier. The upward path, at least in the case of Lava doesn't technically define any sorts of formats. It lets your test just spit out whatever they want, right? You can use Lava test shell and get signals that Lava can interpret, but it doesn't define any other types of.
Yeah, but I guess it's in the level of the results that are already stored in the database.
If you use Lava test shell, you can have results stored in Lava's database. But if you actually want to extract them from Lava and put them into some other tooling, you don't really need Lava test shell. You would still need this standard format that you could post-process and digest into your database.
Lava gives you the results in the API, so then you just put into the format from using the API.
That's why having tap output or JUnit output was on my wish list, right? Because that's at least a accepted format, which apparently I should have asked that earlier on the mailing list, because now tickets are added for that. Because really what it has right now is, for results, is CSV and YAML, right? And there's some other way to get the log info out of it, but...
Is JUnit complete enough for this?
I don't-
this type of thing? I mean, I know some people are already using it, so I guess that's a question.
That's a whole nother discussion, right? Because I know we can talk about those formats being standard, but then there's the question of does it actually meet all of our needs? I have those concerns too.
Or is it at least usable as as kind of the initial interchange format, right, or the starting point? Because not everybody's going to ingest JUnit, but clearly JUnit is broadly used already. So I mean, it might be the obvious starting point. I mean, to me, TAP 13 and JUnit are slightly different things, right? TAP 13 is just kind of an output syntax, where JUnit seems to be a little bit more of a collector type of definition. At least that's my understanding of how it works.
TAP is machine readable, at least the spec says so.
But I think you can add more info to JUnit. You can embed more info into JUnit than you could into TAP. But then again, people seem to hate XML, so.
It's automated testing. We only care about machines anyway. But more seriously, as long as you can translate out of JUnit into something a human might want to consume, if it's more extensible, then maybe it's the better choice.
I think, especially since JSON schemas are still kind of not really a thing. I mean, they are, but they aren't at the same time, right?
They're also very flexible. I mean, people are creating schemas, but they also just keep changing.
I think the other thing is looking at databases, right? Is all of us come from usually using SQL databases and that kind of background, but the trend right now is to not do that, right? Like it's NoSQL stuff, MongoDB or InfluxDB or something like that. It's changing what's happening, and that's not exactly related, but it's close.
So do you guys think that the database type of discussion is important to have for this meeting? It seems like so my opinion is this interchange format is much more important because we can ingest it into any other tools. Okay, I see everybody's head nodding, so let's not worry about having NoSQL versus SQL battles.
It seems to me that to have a useful interchange format for the result of runs, we also need to have a matching format for the test definitions. Because if you want to make sense of these results over time and compare to what other people are running based on the same test suites, we need to have some way to correlate our results with results from other people.
Yeah.
It needs some format or interchange format for test definitions.
Well, basically one thing we are looking for in LTP is some kind of defined structure for the test description, because as it is now, there are some comments in the header of the C code for the test that are trying to describe what the test is doing, but it wouldn't hurt it if it was in some more structured format. For instance, if the test is a reproducer, there is usually kernel commit ID fixing the bug. And it would be nice if that was in some kind of structure, so you can extract that and include that in the output. So you could just simply check if the kernel has this commit or not, and stuff like that. So yes, and actually I wanted to look into that, but I haven't had time yet, as it is with other to-do items I do have. But yeah, I would love if we had some kind of description format we can put into the test case and automatically process that and create a database of what we actually have in LTP. Because at this point, even I don't know what's there. And I've been maintaining that thing for, more than 6 years.
I mean, from my perspective, I've actually got a different view. I don't think that you really need the test definition to make this work. What you need some kind of identifier. But as long as you have the identifier and you have some kind of result, which is pass or fail or whatever, I think that is enough. And that's why when we did the p-test stuff, we kept it really simple. Identifier, pass and fail.
And that identifier allows you to get back to the build then that triggered that, presumably, or?
Yeah, I mean, the build ID would be something that would be recorded at a higher level than p-test. So that is something that gets, further in. And as long as you know which recipe it was, so you know it was LSB, or you know it was LTP, or you know which set of tests it was that was failing, you know the identifier within that test suite. To me, that is enough to at least then be able to identify where it was in the system and put that into some result system.
Sorry, that was louder than I expected. The use case I have that I think you're missing, or that I think the difference between what you're describing and what I'm trying to achieve, is that I want people who don't know anything about the test apparatus and the test automation and stuff like that to be able to take a look at a failure and reason about it, who may not be involved in the project at all. And this is a consequence of testing something that is outside of what you're developing.
I totally agree it's nice to have. What I disagree with is whether it's essential, because I'd really like to be able to get to a point where we can at least sort of work on some sort of common visualization tools or common results analysis without necessarily having to have a common test definition. So I 100% agree, I like the idea and I'd like to see it, but I don't necessarily see that. If you try and tie the two together and solve both problems or none at all, you run the risk of just not solving anything.
I think it needs to be achievable, but it doesn't necessarily need to be done immediately, so long as it's extensible, or it's possible to hang that data off. But they are separate bits of data, and you just need a way to connect the two together.
Exactly, yeah.
Yeah, so the way I'm thinking about it is if it's not necessary if I just want to look at a set of runs for the same type of let's say it's Yocto p-test or something that's running LTP, but if some other system is also running LTP and I want to compare, that LTP version on this board and that LTP version on this board that came from different places, which is what kernel CI cares about, is collecting stuff from different suites, then I think the correlation between the test definition and the output I think is important. But yeah, I agree, it's more of a add-on feature than an absolute requirement. But
and as long as LTP has standard identifiers for its tests, then you can at least get to that point, even if you don't agree on the full description.
Yeah.
Richard, on the p-test level, do you have any information about how to interpret the results? Like Tim said, do you want to have them in a table or in a graph? Or where would that information come from?
We actually care about comparing the results. We care about regressions. So we know right now that not all our p-tests pass, but we care about things that have passed in the past but are no longer passing. So we want
just pass and fail.
Yeah, it's pass and fail, but we're very interested in how that compares to previous runs and trends.
So Carlos, you had mentioned earlier like the importance of connecting the test definition and the output format. Maybe now you can elaborate. You want to elaborate on that a little bit more, what you were getting at when we cut you off?
Sure. I mean, if you want, I can show an example.
Sure, yeah, if you have an example, that's great.
I think sometimes it's easier to discuss something if,
Let's hook up to this. Over here, let's do this. Do you have HDMI?
I think so, yeah. Wow, looks really small. Yeah, I think is it readable?
Which part?
So this is test link. So this is the test management system I was mentioning earlier. Again, this is an open source project. This is like a small test plan. You can see it's like a daily test plan. So it's very small regression test plan. But the main thing is here you see summary. It briefly describes what the test case is about. In this case, we're not describing any like manual steps. Typically, if you have manual test cases, this will be manual, the execution type, and then in the steps you will describe everything that you need to do. But nowadays,
It means you have in the system manual tests which
We-
someone has to pass, and the
Okay.
description is that.
yes, there are manual test cases defined test link, but we don't use them anymore.
Okay.
Nowadays, everything is.
And what was the origin reason why you have done that? Did you miss the infrastructure stuff, or?
No, it's like we couldn't scale. We couldn't run manual tests. So we have to say whatever we don't have test cases for, at least in my team, we'll take it as a test gap.
Yeah. So
I tell you one thing. Okay.
we have, for example, a test for the QSpy, right? And we have a slots, and there is a requirement just to exchange a QSpy for testing that stuff. It means this is a manual process because someone has to be there and exchanging the QSpies, right? That's some sort of manual test. Just extending running something, then just to run the.
I think we do have automated tests for. I mean, opening this is a whole test suite, and I mean, I'm not gonna go through, but you can see there are quite a lot of test cases there on different test areas.
Are you going to share this?
Yeah, I mean, this is what I was mentioning earlier, that it would be nice if we can agree on a place to share this type of information.
Yeah. So yeah, I mean, manual tests are definitely a thing that we should consider. I'm aware of a bunch of things where they're inescapable, like that. People doing production shipping of things, for example, will generally want to have at least one human look at the thing and go, yeah, that's working, just to confirm that their test suite worked. And that there's other things involving mechanical insertion and deinsertion where I'm not aware of anybody having sensible automation, even with sort of mechanical assist.
So just to finish on the test case definition part, so summary or description steps. Then here we have, this is what I mentioned earlier today. For me, this is key, having test execution engine type. You can see here is BATF, but we have other test cases where this is Lava, or other test cases where this is STP, a Python-based execution engine. So I think if we can agree here to have something like this that goes a little bit, a layer above the actual execution engine framework, and define to run this test case, this is the execution engine that you need, I think it will be a good step, in my opinion. It will allow us to reuse test scripts from each other easily. Because I don't think we're going to agree on, we're going to define, this is the interface, and everybody will move all your existing thousands of test cases to this interface next year. It's not going to happen. I think it has to be a...
I have one worry with that. For some tests we do, we have 5, 6 different methods of running it in the executor engine. So I think that's a very hard problem to solve. The thing they all have in common is the output and how to visualize that and how to run through that. I think that's for me a much bigger problem to solve than this high level.
Oh, okay, so you're saying in the execution engine itself how to run the test? That problem?
Well, there's so many different ways of doing that, and that depends on what kind of image you have, where it got built.
Yeah.
So, but so that's back to the definition of what's a test, right? Yes. But
the engine is the same. It's like the point. So we run the test in Lava. Lava is your execution engine, or you run it in like Autotest or whatever.
But some things I can't run in Opentest that I can run in Lava and the other way around.
Yeah, so that's exactly the point. That's exactly the point that Carlos is making. So you have your test embeds the idea of the test executor. So you say this test can be run in this executor, full stop.
I would call that a test plan, but that's back to the jargon again.
Yeah, I know.
Yeah.
Well, in a test plan, I would add the variance. Like, so test takes like vector of variance, and then this is your test plan. Right? Run through each of the variants.
That's a template for a test plan.
Yeah.
That's But I guess my worry is a bit that we're trying to start at a very high level, and there are 5 levels in between that also aren't solved. So
here I just brought, just to bring the point. So I open another, again, this is the same test link, same, and I just went to a different test case in the specifications. You can see the test engine now is Lava. So I think this is pretty powerful to allow you to decide.
I fully agree. I just think we're looking at solving too many problems at once.
Yeah, what I was going to say, I think what Short is saying is that we have like a couple hours left to kind of, and if we're thinking about low-hanging fruit, maybe the output formats and the results processing and that type of thing, and how to ingest it into various visualization engines is maybe the easier problem to solve.
Yes.
And but that will also, if we start doing that and have common ways to ingest and visualize data, it will start triggering more things that we actually need to put into the test definitions so that they end up trickling into the data we're outputting and visualizing.
All right. So I think that was all I wanted to show on the test case definition. I think the rest, this is once you identify the engine, then the script or logic that you want to run on that engine, and then require hardware assets. So this will help your scheduler decide, to run this particular test case, what do you require? And you can see, you can not probably read it from the back, but here it says, this is kind of a platform placeholder that it gets replaced on the fly when you define your, when you define your build description here, this platform, this is what makes the test case kind of agnostic, platform agnostic is, and then when you create your test plan, you add the build information that identifies your software as well as the platform that you're going to use, and then that kind of gets the platform value gets replaced on the file with the rest of the parameters.
Does TestLink actually define a spec for this thing already that you're just using and extending?
No, these are kind of extensions that we did on top of, or conventions, I will say, that we did on top of TestLink. And we have documented in the Opentest wiki the language that we use to identify these hardware assets. For instance, sometimes we have test cases that require USB host MFC device or HDMI or power measurements, all those. So you will put those as what we call hardware capabilities. So these required hardware assets is a collection of equipment types and equipment capabilities.
Okay.
So each equipment type can also have its own capability requirements.
Got it.
And then one test case can have many of these. And then the final is application parameters or test parameters, stuff that you are usually gonna be consumed by your test script or test logic. I mean, in reality, it's only like 6 or so parameters that makes the test case definition. I mean, of course, this is an array of. But
can you show the output side of this as well?
I'm sorry?
Show the output side of this as well. So this is all the inputs to get a test run to go, I guess. So what's on the flip side?
There are many. At the end of the day, our reports looks like this. So here you have components to component, the requirement. Each requirement is associated with test cases. And then when you go to any test case, I don't know, I'm gonna pick here I don't know what this is. So you can see all the different pass fails. And if you go into any of these tests, then you can see the actual kind of the output from the framework. But I mean, you have all the DUT logs. This is server logs. This is on the host side. So these DUT logs contain some annotations, like stuff we send and responses, kind of a Lava, how do you call it? Lava also has a view where it contains all the whatever you're sending and whatever you are expecting or receiving. So that's kind of like that, but this one is just the raw no comments kind of output. We have pass, fail, or skip. Like whenever we detect that we couldn't run the test because a build config was not enabled or there was a test setup failure, we will classify that as a skip here. And we usually will add a comment saying why we skip it. But it's essentially pass, fail, the comments, of course the logs, and the performance data. That's our result. And our results in the way we define it in Opentest is XML schema for the results, XML schema for the test case definitions. But as I mentioned earlier, you can transform that into whatever your framework requires.
Do you have some visualization for the performance metrics as well, or is that just comments?
Yeah, we do have. Actually, yeah, some of them are. I can show. We do have a couple of.
Let's just do a couple more minutes on that and then we'll move on.
Yeah. Well, so we do a couple of different things. We have some performance reports with tables that we publish on either wiki or restructured text, and that's public. I mean, if you go to ti.com, you will on Linux performance guides or something like that. You'll get the links. We also have some graphs that we use internally to track how a particular metric is moving, over time. Those are more for internal consumption.
You can keep that one.
I don't know, you have any questions on the test case definition or on the output?
I think the output looks pretty nice from what I've seen thus far. I guess that also gives you a good idea of what the requirements are for what such an interchange format should look like, as you probably already have one.
Yeah. Well, I mean, it's a good point, but I just want to show this really quickly. We use Jira for our requirements. So, and then since we have Jira requirements and we have test links, we have a Django project where we can kind of connect, do the mapping between requirements and test cases, and then that's how we are able to generate those reports where we say, for these requirements, these are the actual test cases associated, and this is the pass-fail, etc. But we are using Atlassian Jira, which is not open source, I guess. But I mean, you could use other tools, right? At the end of the day, here, there is some abstraction about, okay, how do I get that requirement data? But we have the logic to get it from Jira, but you could implement another piece of code to get it from somewhere else.
Yeah, and I think what Richard was saying earlier is quite powerful. You need some kind of way to identify which build or test run, which can be whatever metadata you need, right? And then well-known identifiers for the specific test cases, and then some system can hook those back together at some point.
Mm-hmm.
Right.
Yeah.
So since we've got Elasticsearch up there, I think Dennis told me. Seeing Elasticsearch up there reminded me, I think Dennis told me that you guys are looking at or using Kibana for some graphing, because so Kevin and I've talked about that a bunch. So
yeah.
when we talk about visualization, we're probably jumping the gun, but I just.
Yeah, we're jumping the gun, but let's get there in a little bit.
Okay. Anyway,
let's first talk about pass-fail criteria, I think, and then we can talk about visualization stuff, I think.
All right. But since you asked, each of these circles here is a rack in our farm with different equipment, and then the outer circle is pass-fail skips. But I guess we'll talk about visualization later.
I'm just looking for the agenda. I can't. Oh, there it is. All right, I can switch back. Let me switch. You can keep that. I'll take this. See if I can figure out Tim's Windows laptop.
Step 1, install Linux.
Okay. Right. So I think this is where we were. Yeah. So one of the obvious things that we're looking for in this output format and output log is the basic kind of pass-fail type stuff, right? So I think the big question that Tim and I were having, especially because Fuego does this differently than some other systems, is basically where you store it. Where should the criteria for the pass and fail type of test? Obviously, some tests are very simple. They can detect themselves whether they pass or fail, and they report that themselves. That's the easy case. But there's a lot more tests that spit out a number or spit out a benchmark or spit out something, and the pass-fail criteria is actually relative to the previous performance of those tests, so you can't actually tell right when that test runs whether it's a pass-fail. You're actually going to want to do that later.
And it might be board specific.
Yes, and specifically it might be board specific, or it might be specific to your test target in various ways. How much memory it has, or what your expected battery life is, there's all sorts of things. So the question, I guess, for the room is how are people currently defining those things, and where are those decisions actually happening, other than the obvious ones that are actually already happening just on target when the test runs. As an example, like Dimitri was here earlier. Is he still here? Syscaller. Dimitri was here earlier. We're talking about it. In his case, the Syscaller bot is basically kernel fuzzing bot, and basically the job of the kernel fuzzing bot is to crash the kernel. Right. So if you crash the kernel, that's considered it's kind of a success case because it allows you to find the next bug. But the success, so it basically is if the kernel does not panic, that's a pass. Right, so it's a pretty low bar. But then if the kernel does actually panic, then there's all sorts of things you want to compare to previous ways that it panicked in those types of fuzzing cases.
So we have a lot of our tests that were written in PyTest, and I don't like it, but we ended up putting some of the logic into the tests themselves. And especially when we talk about benchmarking and things like that, where it's a new numeric value that's dependent on all kinds of other factors, I really, really don't like putting it there.
You mean you don't like putting it in
the test itself? So we absolutely need to find another place to store that and use it.
So does PyTest define any other ways to do this? This is an area of PyTest that I don't really know. Does PyTest have other ways of defining criteria for pass-fail or for test results? I guess you guys know, you use PyTest a lot as well, right? Or maybe Richard. It's behind you.
Yeah, I mean, I'm not 100% familiar with it. I do a lot of Python unit testing, but I think it is specifically pass, fail, skipped. There is no way of reporting a benchmark back. Yeah, but
but it is pretty easy to extend it with plugins. So you can have test pass and add additional performance data to the result that could be evaluated later.
I see. Okay.
You might even get that upstream. Yeah, I mean, we extend Python unit testing quite a bit with our own classes, and adding that kind of results data in would actually be fairly straightforward.
I think there are existing plugins doing that.
Quite likely.
So is anybody doing the more Dan?
Yeah, it seems to me that you need a layer after you collect the results that looks at the results and decides whether or not there's actual problems. And it's not enough to just post the passes and failures. You really need something to do analytics on that before you can have meaningful data to report.
I mean, one other area where we do collect data with the Octo project is to do with build performance. So it's the same kind of numbers data that we get out of there. And we gave up trying to sort of come up with any kind of algorithm that did it from a machine perspective. But what we do is have an email report comes out with graphs in. And it's usually very, very obvious from the graphs, you know, based on previous numbers, whether something went wrong.
Okay.
Yeah, so just add some thinking. So one aspect of zero-day side is bisection and orientation. So we try to not judge the result simply, because sometimes the failure may be introduced by the test suite itself when we do the upgrade very frequently. So we try to compare to a previous base by running the same version of the test suite. If it has the same result, so we will treat that fail as a safe one. So if it results differently, we will trigger the bisect, try to find out the reason. So we have the capability to bisect through different dimensions. For example, we can go through the kernel repo, or we can go through the test suite repo, so we can identify the issue. Yet I think this is the way we try to avoid too early judgment. Even for the benchmark result, we will compare to several results previously and try to find out a threshold. Yeah, if the threshold is large enough, so we think it may bring some impact to the kernel. Yeah, so we will try start the bisection.
Yeah, so I think the question here is how do you define that type of thing? How do you define what those thresholds are and how many bisections you're going to do, and how manual is that process versus how automated? I mean, this is a big mystery for zero-day to me. I don't know how. It seems like tons of stuff is automated, but you guys also do quite a bit of manual stuff.
Yeah, I think it's kind of like a post-mortem process.
Yeah.
So we didn't do it right at the first time, but we will do data analysis. Also, we get a lot of feedback from the community. Yeah, so we will do internal tuning. Yeah, but it's not fully automated.
Right,
it's not. Yeah, that's smart.
Yeah.
How do you?
That's where I'm trying to go, though. Is actually
is
to take that. You know, as Richard said, we can look at the graph and see it, right? Well, that probably means there's statistics in there.
Yeah.
There's data in there. There's a signal in there that can be captured automatically by AI. It's not. I'm not saying it's easy. I just it's got to be possible.
I have a question for zero-day specifically, but for everybody, how do you deal with false failures when you get a failure that's not really a failure, and you only get it sometimes?
You mean how we identify the false failure?
What do you do? Yes. How do you identify it, and what do you do about it?
Yeah, basically we will do the comparison with the previous kernel base, like just as mentioned. We will run the same test version on different kernel versions. So we can compare the difference. If we see there's some change, so we will guess it's maybe a regression. Then we will trigger the bisect. And most of the time, the bisection will successful identify the real change. But sometimes the bisection fails, so we ignore the result.
Oh, so you do the bisection automatically, and if the bisection fails, you assume that it's a bad test?
Yes, because currently zero-day don't have enough resource to figure out all the failures. Yes, so we mostly focus on the high confidence ones. Yeah, so it's maybe not a very good answer, but it's just how we currently do now.
It's not the answer I expected.
Yeah, so the problem that we had, that Dan is probably interested in, so we have some tests in that like every second build they fail, because they base on some performance that's hard-coded in the performance expectation that's hard-coded in the test case, for example. And the test case was designed to run on a server, and it's running on the embedded board, and it fails every second time because of the ambient temperature, for example.
I mean, second time is one thing. I mean, our worst case for Yocto project was where we had a failure that was happening once every roughly 2 weeks. And it was in a virtually emulated machine. And it turned out to be an APIC emulation bug in KVM. So, yeah. Which wasn't what we were trying to test. It took us a long time to figure that out. We did get there, but we have spent a lot of time trying to narrow those things down. It does help, I think, the Linux ecosystem in general, but it's sometimes very frustrating when you're in the middle of it.
When that happened to us, they said, "Oh, it's the test framework," so they don't look into it.
So I don't remember if it was that bug, but we had a thing that only failed about 1 in every 10,000 runs. And so what one of our people, Randy Witt, did is he actually put it into a Docker container, and he ran 100,000 Docker containers over the weekend, or 100,000 test runs over the weekend, and absolutely proved where it was, and then we could fix it.
To comment, I think earlier you were asking about performance, pass-fail, how to determine. So what we do today is we keep a running average of the particular or each metric on each platform. And to keep the running average and to make it storage efficient, I guess instead of saving all the values that you have, you only save the number of samples, the sum of the samples, and the sum of the square of the samples. And that way, with these three values, it allows you to keep the running average alive. And then whenever you run a test, you ask the library, what's the mean and standard deviation for this particular metric on this particular platform? And if we are outside the one standard deviation, then we fail the test. If we are inside, we'll mark it as pass.
There's another level of decision making I want to talk about briefly, and then we'll catch up to. We're just finishing our break technically here, so let's do that. But one other thing is like this level we were talking about of nesting, right? We talked about test cases and then test suites that encompass everybody's doing something like you have a test suite with 100 test cases. You mark each individual test case as pass or fail. And then the grouping of that gets marked as pass or fail based on some criteria, right? Maybe I'll accept 10% failure or something in that. And that type of thing is also really like hand wavy. Everybody does it, and just kind of like most of the time 10% or more or less are failing, so we'll call that a pass, right? But that's the same type of thing. That gets defined someplace. And it typically gets defined kind of arbitrarily and randomly and hard-coded someplace because nobody's very proud of the way they're doing it. But at some point, that if we're going to standardize, if we're going to agree on what it means for especially common open source test suites to pass or fail, we have to document that someplace as well. So that this is the type of thing where pass criteria kind of needs to live, at least with some of the common test suites. We need pass criteria, I think, needs to live with the test case itself. But again, there's so much, like you were saying, that some of the stuff is board specific. There's all sorts of expected failures that are different. So I don't really know how to get around this, but
you have to fix the tests.
That's also negative testing.
Negative testing.
Random testing.
Random. Well, yeah, all the fuzzing stuff and random testing. Yeah. So anyway, I mean, but I think, I guess what we're doing today is rehashing a lot of the problems we already know about, but like maybe the easier ones are bubbling to the surface, so we can try and tackle them as the low-hanging fruit to tackle first. So let's take a quick break. When we come back, we wanted to do at least maybe we'll split up the room for people who want to talk about board farms and specific lab setups and that type of thing. We'll split a group, and for other people that want to talk more about test framework stuff, sharing some of these resources, we'll split up that way because I don't think we're going to be able to do both. But one idea that Tim and I talked about is I think Tim was hoping we would be able to come up with standards for PDUs and board farms and all this type of thing. And I think maybe in 10 years we'll get to someplace like that. I think the low-hanging fruit for standardization is much more on the, where's my diagram? We don't need to, well, my opinion is standardizing this type of thing is a losing battle. I think it's not a losing battle for short term. I think standardizing this type of thing and this type of thing is stuff that's actually achievable in the short term. And if we get there, if we get to the point where we're agreeing on test formats and run artifacts and how to parse them, that's going to imply certain ways of doing things in our labs, and I think that's a better goal. So at the same time, a lot of us are doing things that we could share here, so I do want to spend some time where we can talk about, some of us that care about board farms and stuff can talk about that type of thing, but I know it's not interesting to everybody, so.
I think Tim touched on one thing earlier which is quite interesting, and I think it also might be a good place to try and concentrate, which is being able to run connect a board up to your sort of local computer and then share it into some kind of test framework or run tests. And having some kind of standardized hardware that you can just, cheap, that you can go and get from one of the standard manufacturers that will connect it up. To me, if we solve that problem, I think some of these other things would naturally then self-select.
We get a lot more hardware, okay.
Yeah. So that's just my 2 cents on that. But I mean, Tim hinted at it earlier and said we'd discuss it later.
Yeah.
I don't know quite where that's going to get discussed, but I didn't want to lose track of it.
That's the thing I wanted. That's the thing I think that would be a valuable discussion when we break out into talking about board farm. If everybody wants to talk about that type of thing, then we can do it all together. But if some people want to continue talking about more of the high level stuff, we can split into hardware and board farms and then infrastructure stuff. So let's take a break and we'll decide after. And I know Pavel will have plenty of talk about for the standardized hardware, so.